Bismillahirrahmanirrahim. In the last video, we have discussed the linear differential equation or the separable differential equation. And we said that some differential equation can be solved by separating the variables x from y, keeping the variable y in one side and the variable x in one side, then integrate to find the solution of the differential equation. Some other equations can't be done by that way, and the sum of the linear equation, which has the form dy by dx plus b of x, q of x or y equal to q of x. This is general form of the linear differential equation. If we have the variable y or b of x multiplied by y, so we have three terms. Keep this in mind. If b of x is not equal to 0, so the equation is linear, dy by dx plus b of x times y equal to b of x. This type or this form of differential equation cannot be solved by separation of variables. So we have to do it in a different way. And the technique that we are going to discuss today for the integrating factor method. The method of the integrating factor. How to do this with the method of integrating factor. For the integrating factor method, we have three steps. Step number one, we need to calculate mu, which is equal to e to power integration of b of x dx. This is the first step. Calculate the integrating factor mu equal to e to power integration of b of x. This is the integrating factor that we are looking for. Take the coefficient of y, integrate it and raise it to the power e. So it is e to power integration of b of x. Step number two, multiply the equation by mu. So the equation will be mu multiplied by dy by dx plus mu b of x y equal to mu multiplied by q of x. Or it is e to power of b of x dx by dy dx plus e to power b of x dx multiplied by b of x y equal to e to power multiplied by q of x. But we notice one thing, the left-hand side, this one, can be written as derivative of product rule of two functions. Because this is the derivative, if we apply the product rule, the left-hand side can be written as d by dx of multiplied by 1. Left-hand side is just the derivative of the product of these two functions. It is derivative of e to power integration of b of x multiplied by y. equal e to power v of x dx of x, or it is just d by dx of multiplied by y equal to mu multiplied by q of x. Now if we integrate integration of d by dx equal to integration of mu of x dx. But we know that the integration and the derivative are inverse of each other, so this will cancel. I will have only mu y equal to integration of mu dx, or it is y equal to 1 over mu integration of dx. So this will be the solution for the differential equation. This technique is called the method of integrating factor. Mu is the integrating factor. So this is the idea of solving linear differential equation using the method of integrating factor. Let's have some examples. Solve the differential equation. Number 1. dy by dx minus y equal to e to power 2x. Now I have to solve this differential equation. And this equation cannot be solved using the separation variable because I cannot write or separate the variables keeping y in one side and x in the other side. And since it is just taking the general form of linear differential equation, I have 3 terms: derivative plus or minus b of x times y equal to q of x. So the best way is to use the integrating factor. Now to solve this equation, the steps is find b of x. What is b of x? From the general form, we have dy by dx plus b of x y equal to q of x. So the b of x is the coefficient of y. So in our example, the coefficient of y equal to -1, which means taking the integration of b of x dx is equal to integration of minus dx equal to minus x. Now the integrating factor mu is equal to e to power integration of b of x dx, which is equal to e to power minus x. It is e to power minus x by this one. Now to find y equal to 1 over mu multiplied by the integration of mu times q of x dx, which is equal to 1 over e to power minus x multiplied by mu is e to power minus x times q of x. Q of x is the right hand side of the equation. That is e to power 2x dx, which is equal to, this is 1 over e to power minus x, can be written as e to power x multiplied by the integration of e to power x dx. I will add the bar. E to power minus x times e to power 2x is equal to e to power x. So this will give me y equal to e to power x multiplied by integration of e to power x is e to power x. And since this is indefinite integral, I must have constant c. So y equal to e to power x multiplied by e to power x plus the constant c. So this is the solution of the differential equation. We can open the brackets to say it is e to power 2x times c times e to power or plus c times e to power x. But I will leave it as it is now. So the solution for the given differential equation is y equal e to power x multiplied by e to power x plus the constant c. Let's take another example, number 2. Try to solve the equation y prime plus y equal to sine e to power x. Let's try to solve this differential equation. So let's find b of x. B of x is the coefficient of y when it is in the general form. So the coefficient of y is equal to 1. Now the integration of b of x dx equal to integration of 1 dx, that will be x. So the integrating factor now, mu, is equal to e to power integration of b of x dx, which is equal to e to power x. Y will be equal to 1 over mu multiplied by integration of mu times q of x dx, which is equal to 1 over e to power x multiplied by e to power x times sine e to power x dx. That will be e to power minus x. Now the integration of e to power x multiplied by sine e to power x, this can be done using the integration by substitution. This is by substitution. Integration by substitution. Take u equal to e to power x, and it will be easy to find the integration. And the integration of this one will be minus cosine e to power x plus constant c. And this will be the solution of the differential equation. It is y equal e to power minus x multiplied by minus cosine e to power x plus the constant c. Take one more, number 3. dy by dx plus 2x y equal to 3x. As we did before, I need to find or calculate the integrating factor first. So I need to find b of x. P of x is the coefficient of y, so it is 2x. And integration of P of x dx, that will be integration of 2x dx is equal to x squared. So mu will be e to power x squared. E to power the integration of b of x. So mu equal to e to power x squared. Now y, the solution is written as y equal to 1 over mu multiplied by mu times q of x dx, which is equal to 1 over e to power x squared multiplied by e to power x squared times q of x is 3x dx. And this will be written as y equal to e to power minus x squared integration of e to power x squared times 3x. This also can be done using integration by substitution. Let u equal to x squared and find the integration. It will be 3 over 2 multiplied by e to power x squared, and it is indefinite, so we must have c. So the solution is y equal e to power minus x squared multiplied by 3 over 2 times e to power x squared plus the constant c. And this will be the solution of the differential equation. Take one more. Number 4. Dy by dx plus 3y divided by x equal to e to power x divided by x to power 3. Let's find the integrating factor for this one. Now let's find b of x first. This equation is in the general form. So the b of x is the coefficient of y. Just remove y. What is remaining will be p of x. That will be 3 over x. This will give me integration of b of x dx equal to integration of 3 divided by x dx, which is equal to 3 ln of x. 3 ln of x or ln of absolute value of x. Just assuming that x is positive. 3 ln of x. Now mu will be equal to e to power 3 ln x, or it is e to power ln x to power 3. Using the property of the logarithm, this is a power. So it is e to power ln x to power 3. And from the properties of logarithm, e will cancel the ln, so I'll have x to power 3. This is mu. So the solution of the equation y equal to 1 over mu multiplied by integration of mu times q of x dx is equal to 1 over x to power 3 multiplied by mu is x to power 3 multiplied by e to power x divided by x to power 3 dx. This one, simplify. Then I will have y equal x to power minus 3 multiplied by integration of e to power x is e to power x plus constant c because this is indefinite integral. So the solution is y equal to x to power minus 3 multiplied by e to power x plus the constant c. And this will be the solution of the given differential equation. Y equal x to power minus 3 multiplied by e to power x plus the constant c. So this is the idea of solving linear differential equation using the method of integrating factor.